Welcome to the DragonCruiser. We're actually coming to you today from quite a spot. We're sitting on an overbridge looking out over this massive express road right here in downtown Shenzhen, China.
It's really something, isn't it?
Yeah, it's about 6 p.m. Sun's going down. The evening's starting to, close in. And right over there, you can see the main CBD, clear as day, that really tall building. City's tallest, second tallest in the whole country. Almost glowing now.
There's just this incredible energy, isn't there? Constant movement.
Total palpable. A real hum of motion, innovation. It never seems to stop. And, well, that sense of relentless global movement, that competition. That's exactly what you're getting into today.
Right, the big race.
Exactly. We're exploring this intensifying global race in engineering and manufacturing, especially, between the giants like the US and China.
It's definitely not a simple picture. Lots of shifts happening.
For sure. It's complex. Talent and technology are obviously huge factors. So our goal today is really to cut through some of the noise, give you a clearer idea of the different viewpoints, and maybe figure out what's really going on.
Sounds good. Where should we start?
Okay, let's tackle this first big idea that keeps coming up. The U.S. might be falling behind, at least in producing the engineers it needs. Is that just, anxiety talking, or is there real data behind it?
Oh, there's definitely data. And it's pretty stark. If you look at mechanical engineers, for example.
Okay.
China's putting out over 350,000 graduates a year in that field alone.
350,000.
Yeah. Compare that to the U.S., it's fewer than 45,000. The difference in sheer volume is kind of hard to wrap your head around.
Wow. Okay. That's a massive gap. What about STEM overall?
It gets even broader there. Projections for 2025 show China hitting about 3.57 million STEM grads annually. That's like 40% of all their degrees.
40%.
Right. Meanwhile, the U.S. is projected around 820,000 STEM grads per year, which is, still a lot, but It's only about 20% of U.S. degrees. The scale comparison is just unavoidable.
Okay, so the numbers are huge, and then you add in things like, didn't China just pass Germany and Japan in robot density last year? Something like 470 robots per 10,000 workers?
Exactly. So they're not just graduating the people, they're deploying the tech at a massive scale, too.
And the USI, the Bureau of Labor Statistics, is saying we need another million STEM pros by 2030.
That's the forecast. So the demand is there, or at least projected to be.
So the big question then is, why? Why is this happening in the U.S.? What's behind this gap?
It's complicated. There are a lot of factors. It really starts with the education system itself.
How so?
Well, for one, the engineering curriculum often gets described as really, really difficult and inflexible.
Okay.
You've got maybe 2 years of intense math and science, very theoretical, before you even get to the cool engineering stuff. That can lose people.
Right. It's not immediately motivating.
Not always. And then there's the structure. It's often lockstepped. Miss one required course, and bam, you might need an extra semester, maybe even a whole extra year. That's a big turnoff.
Yeah, I can absolutely see that, especially when, like some reports point out, you've got fields like computer science that maybe seem less daunting, but pay just as well, maybe even better.
That's definitely part of the perception. Plus, there's this idea that engineers sometimes get treated like commodities, more prone to layoffs, moving sideways instead of clearly up.
And haven't a lot of those entry-level support jobs been offshored? Does that play into it?
It does. Fewer entry points domestically, maybe lower starting salaries offered. It all feeds into this narrative, sometimes fueled by media reports about instability in the field.
Okay, so curriculum, other job paths, offshoring.
Yeah.
What else?
Well, there's a really fundamental issue, maybe the most critical one. Some people are calling it America's math meltdown.
Oof.
Yeah, it's blunt, but look at recent scores. Math scores for 13-year-olds dropped 9 points since 2020. Only about 26% of 8th graders are proficient in math.
26%? Wow.
The pandemic definitely made it worse, but these foundational issues aren't going away quickly. And if kids aren't solid in math early on, pursuing engineering later becomes, really difficult.
It's like the foundation's crumbling before you even start building the house, isn't it? You're narrowing the pipeline right at the source.
Exactly. And it's not just overall scores. There's a diversity issue, too. Engineering classes are still less than 20% women. Minority representation is often way below community levels.
Why is that? Still stereotypes. Prerequisites.
Both, probably. Many opt out before high school because of the math science requirements or just feeling like it's not for them. And then even at the PhD level. We saw a dip in native-born PhD students after the dot-com boom. The U.S. relied heavily on foreign students, which was great. But that's slowing down. Post 9/11 visa issues didn't help, and now countries like China and India have built strong programs, so they're keeping their best talent home.
Okay, I'm hearing all this, the numbers, the pipeline issues. It sounds pretty serious. But then you also see things like from Rebuild Optimation arguing there isn't actually a widespread shortage. They're saying the market works, there are more grads than good jobs. How do those two things square up? Is it just industry trying to keep wages down, maybe?
That's a really crucial question, and it shows just how messy this is. You absolutely hear anecdotes about grads struggling or companies wanting experienced hires only or using H-1B visas. That's real.
So maybe the shortage narrative is overblown.
Well, I wouldn't say it negates the strategic vulnerability. Think long-term. National security roles, critical infrastructure, the kinds of jobs you can't easily offshore. And then look at the sheer scale of engineers China is producing. It points to a potential imbalance, especially for those cutting-edge roles. The old supply and demand rules, they get really bent out of shape when you factor in globalization, offshoring, visa programs. It's not a simple domestic market anymore.
Right, the global context changes everything.
And that brings us nicely to automation, actually, because with the U.S. facing, over 700,000 unfilled manufacturing jobs, automation is being pushed hard as a solution.
Okay, so filling the labor gap. How's that actually playing out on the factory floor? Is it just robots taking over jobs?
It's way more nuanced than just replacement. Yes, robots and AI are doing repetitive stuff, assembly, packing, but they're also doing complex quality control, predictive maintenance, using AI to fix machines before they break.
That's pretty advanced.
It is. And something like 57% of U.S. manufacturers are already using or planning to use AI and robotics, specifically because of labor shortages. And think about cobots' collaborative robots.
Right, the ones that work alongside people.
Exactly. They're designed for collaboration, not replacement. That market segment is growing like 25% a year in U.S. manufacturing. It shows the direction things are heading, integration, not just takeover.
Okay, so if it's integration, what happens to the human jobs? Does it just shift the problem?
It's more about job evolution. This means a huge focus on upskilling and reskilling. Companies like GE, Siemens, they're investing heavily in training workers for new roles.
Like what kind of roles?
Things like robotics maintenance, machine programming, systems integration, managing these complex automated systems. And entirely new jobs are being created too, and data analysis for all the info the machines generate, AI development, things like that. It requires a different skill set, often higher level tech skills.
And temporary staff are plugging gaps in the meantime.
Yeah, staffing solutions are crucial during this transition while the workforce adapts.
It feels like part of a bigger strategy. I remember reading about PwC's 4 imperatives for U.S. manufacturing. Reshore, rebalance, rebuild, and reimagine. Automation fits right into that reimagine part, doesn't it?
Absolutely. It's about rethinking the entire manufacturing process using technology and a skilled workforce.
You know, talking about all this global stuff, sitting here in Shenzhen, it's kind of wild. You feel the energy here, the construction cranes everywhere, the tech everyone's using, the sheer number of electric vehicles on this road below us. It's just constant motion.
It really brings those abstract numbers to life, doesn't it? You see the drive.
Totally. It puts a face on the data, reminds you these are real economies, real people pushing forward. It definitely shifts your perspective being here. But you know, despite all this energy and China's obvious engineering muscle, their manufacturing isn't exactly problem-free either, right? They've got challenges too.
Oh, absolutely. Significant ones, actually, that are causing ripples globally. A big one is just rising costs.
Labor costs.
Yeah. Wage inflation has been huge. Average manufacturing pay has basically doubled over the last decade. Plus, you've got rising energy costs, stricter environmental rules, sometimes even electricity rationing hitting factories. It all adds up.
And then the whole tariff situation. That's thrown a wrench in things too, hasn't it?
A big one. U.S. tariffs on Chinese goods went way up. China hit back with tariffs on U.S. stuff. Plus, China's own restrictions on exporting key materials like rare earths or certain chips adds another layer of complexity and cost.
It feels like a much less predictable environment than it used to be.
Definitely. And you still have supply chain headaches lingering from the pandemic port jams, high shipping costs, geopolitical tensions adding risk. Compliance is getting tougher, too.
How so?
China's enforcing environmental and labor laws more strictly. And then globally, you've got new rules like the EU's carbon tax on imports, stricter U.S. safety standards.
Right.
It all means more hurdles and costs for goods coming out of China.
And the old worries about IP protection and quality control, are those still around?
They are. Weak IP enforcement, counterfeiting. Those remain risks. And inconsistencies in quality or materials can still be an issue. So yeah, while China has been the go-to factory for ages, all these challenges, especially the tariffs, are making businesses genuinely look elsewhere. PwC figured U.S. tariff exposure could leap from maybe $23 billion to over $120 billion a year.
I mean, $127 billion. That's a massive incentive to look elsewhere. But is it really enough to bring manufacturing back to the U.S. in a big way? Labor costs here are still so much higher, even with robots. And if you source the robots from overseas, don't they get hit with tariffs too?
That's where the calculation gets interesting. It forces companies to think about the total landed cost, not just factory wages, meaning you factor in everything. The tariffs, the shipping risks and delays, the cost of holding inventory that's stuck on a boat, the political stability, the benefit of being closer to your customers. So maybe importing components now costs 30% more because of tariffs. Suddenly, paying more upfront for a highly automated factory in the U.S. looks better because the overall cost to get the product sold is lower and it's more reliable.
Okay, so it's about resilience and total cost, not just the price tag on labor.
Exactly. The risk equation has totally changed. Companies have to think differently now.
So for smaller businesses, the SMBs who maybe can't just build a giant automated U.S. factory, where are they looking as alternatives to China?
There are several hotspots. India's a big one, huge workforce, competitive wages, plus their government is pushing Make in India.
Yeah.
But you still have to deal with some bureaucracy and infrastructure issues there.
Right. Who else?
Vietnam is popular, especially for electronics and textiles. Lower labor costs than China, good trade deals. Main challenge is they import a lot of their raw materials, and high-tech isn't their strongest suit yet.
Mexico. Nearshoring seems appealing.
Definitely for North America. Shorter shipping, the USMCA trade deal helps. Labor is pricier than Southeast Asia, though, and some companies worry about security.
And Europe?
Western Europe is great for high-quality precision stuff, strong IP protection, but labor costs are way higher, so it's mostly for niche, high-value products, not mass production. Then you've got places like Thailand, Indonesia, Malaysia, Turkey. Each has pros and cons.
It sounds like a complex map to navigate for a smaller company. What are the key strategies for them to manage all this change?
It does seem daunting, but there are practical steps. First, talk to your current suppliers in China. Can you negotiate? Maybe bulk orders, maybe share tariff costs. Don't just abandon relationships.
Okay, negotiation first.
Second, definitely develop a multi-sourcing plan. Don't put all your eggs in one basket. Spread production across regions to lower risk.
Diversify. Makes sense.
Third, really dig into the government incentives and trade deals in potential new countries. They can make a huge difference to the bottom line. Fourth, use tech. AI and automation aren't just for the factory floor. Use them for smarter supply chain management, forecasting inventory, tracking shipments, quality control.
Use tech to manage the complexity.
Exactly. And finally, lock down your intellectual property. Register it everywhere you operate or might operate. Do audits. Protect your innovations.
Okay, so we've covered the talent picture, the automation wave, China's own hurdles, the global manufacturing shuffle. Bringing it all back. Is China really pulling away from the U.S. in this engineering race? Or is it more like a really complex dance where everyone's adapting?
Well, the argument that China is pulling ahead, at least in sheer capacity and strategic output, remains pretty compelling. That 7-to-1 ratio in engineering grads, it's just hard to ignore the implications of that volume.
The numbers are dominant.
They are. And it's not just quantity. They joined the Washington Accord back in 2013, which is basically international validation of their degree quality. And look at the output. More science and engineering papers published than the U.S. now. More international patents filed. They lead in supercomputing, high-speed rail, solar, batteries. And they're moving incredibly fast in EVs and AI application. It's engineering power being translated into tangible results at scale.
Okay, but what about American innovation? Silicon Valley, the breakthrough research from universities, doesn't that count for a lot? Isn't that fundamental excellence enough to keep the U.S. competitive, especially at the cutting edge?
That's the critical question, isn't it? The U.S. absolutely excels at fundamental research and breakthrough innovation. That ecosystem is unique and powerful. But China's strength seems to be in the application and commercialization of technology. Taking research and turning it into products quickly at scale. That massive pool of engineers lets them do that incredibly fast.
So we invent it, they scale it.
It's maybe an oversimplification, but there's an element of truth there. And our reliance on attracting foreign talent, which worked for decades, is becoming a potential weakness now that China is actively retaining its own top people and attracting them back. We can't just assume the best minds will always come here anymore, especially for critical strategic roles.
So it really sounds like the U.S. needs a fundamental rethink. Does that mean becoming more centralized, more top-down, like China's approach?
Right.
Or can we keep our unique innovation style, but find ways to fix these talent pipeline issues? It feels like we're at a crossroads.
I think it has to be a coordinated effort, but one that plays to American strengths while addressing the clear weaknesses. The research suggests we need policy changes, yes, but maybe focused on enabling our system, not replacing it. Things like serious financial aid to get more U.S. citizens into THD programs.
Right, tackle the pipeline at the top end.
And at the beginning, really expanding STEM programs before college. But also maybe changing the public perception of engineering, making it clear how creative and impactful it is, not just, hard math.
Making it cool again.
Something like that. It needs a national strategy, really, that connects the dots between education, workforce training, and supporting advanced manufacturing, like China did with Made in China 2025, but in an American way. It's not either. It's recognizing that our long-term economic health and strategic position demand serious, coordinated action now.
It's definitely clear things are moving fast. This whole global engineering and manufacturing picture is incredibly dynamic, not static at all. The US, China, other players, everyone's adapting, but the stakes feel really high, touching everything from jobs to geopolitics.
Absolutely. The ripple effects are enormous.
So for our audience, for you listening or watching, what does all this mean in your country, maybe in your own career? How do you think these huge shifts in talent, tech, and trade will ultimately reshape things, not just supply chains, but maybe even global power itself in the coming years? Definitely something to think about.
A lot to chew on there.
Yeah. Well, if this discussion got you thinking, please do give this episode a like. We'd love to hear your thoughts in the comments. What did you agree with, disagree with? And of course, make sure you subscribe to the DragonCruiser for more explorations of the world's really critical topics.